keep learning. Okay. All right. So I am, I actually have the camera focused on the whiteboard so that people who are watching this can actually see the whiteboard. Okay. So, what is a linked list?
A nonlinear data structure.
A nonlinear data structure. In what way is it nonlinear?
Because it's dynamically stored in memory.
What do you mean by dynamically stored?
When you want to store a linked list in memory, you don't need a continuous block. It's distributed.
Okay, all right. So one big difference between a linked list and an array is totally, and I got a funny look from Alex when I used the word contiguous before, but it is, yes, the contiguous is what people actually use. It's stored in contiguous memory.
Why can't they just?
Yeah, because they hate you, Stephanie. So when you have an array, that is why it is constant runtime to get the sixth element of the array. It's constant runtime because it knows exactly where that sixth element is. But for a linked list, you have these nodes, and they could be stored anywhere in memory, right? And it is not constant runtime to get the information stored in the sixth node of a linked list. It is on the order of whatever element you are trying to get. And so to get any element in a linked list, when we're thinking about runtime, we think about worst case scenario. So to get any element in the linked list, what would the worst case be?
The last one.
The last one. And so that would be O of n, where n is what? The length of the list. So getting an item, getting information for an item in a linked list is O of n. Worst case, you need the last one.
That's the same as an array, though, right?
Array is constant runtime because you can go straight to the place in memory because you know exactly where that place in memory is.
That's O of 1.
Constant runtime to get information from any particular item in an array. If I have an array that's like teams, right? And I ask for teams, the seventh team in the array, constant runtime. If I ask for the 300 millionth team in the array, constant runtime. You do not need to look at each of these to find it. Mm-hmm. You just multiply, you take the beginning address in memory, you multiply by however many, multiplication is a constant runtime operation, mm-hmm. and you go straight to the place in memory that has what you want.
When you say constant, I think in my head O of 1. Is that correct?
That's correct. Okay. Constant is O of 1. Okay. Right. Okay. So linked lists. What else did you learn about linked lists?
The specific order in which to like add a node, like knowing which pointer to point to first, and then how to link it.
Yeah. So here's a linked list, kind of a crazy one. And what's that?
Non-linear.
It is. Yeah. It is non-linear. Although, like when I heard nonlinear, I was a little uncomfortable with that because it is a linear structure, right? It's one dimensional. It doesn't branch at all, right? It's just not contiguous. Yeah. Okay. So, right. So if I wanted to add a node, let's say I wanted to add a node at the end of this linked list. How would I do it?
You would have to say the node you want to add, its next is null.
Okay, so I have a node that I want to add, and it's here.
Uh-huh.
And I'm going to make its next be, yeah, so this one really is pointing to null as its next. So its next is null. Okay. Then what?
And then you would say that the last node that you're connecting it to.
How am I going to find that last node?
Tail.
So my linked list has some special properties. It has a head, which is indicating the first node. It has a tail, which is indicating the last node. Okay, so I have my linked list. I know which linked list I'm going to add, so I go straight to the tail. Okay, what do I do at the tail?
So you say tail dot next equals current node. But you have to connect the current nodes next first before you can connect the tail node to the current node.
Or like change the pointer of the tail to this new element.
So this one's pointing to null. That's okay. When you create a new node, in general, by default, it points to null.
Okay.
So we created a new node. We can put whatever information we want in there. Then we find the tail and we make its next point to our new node.
Mm-hmm.
We done?
Mm-hmm.
No. What do we need to do?
So we said tail dot next. So then we need to say that current node is now the tail node.
So we have to take tail, and tail needs to now point to this. So when we need to add something else, we can now go straight to this end here. What runtime was that for us to add something to a linked list?
It went straight to the tail, so it didn't have to traverse. And then, so O of 1, it was constant.
It was constant runtime. We went straight. We did not have to traverse the linked list to get to the tail. We had a pointer right to the tail. And then it was a matter of rearranging a couple pointers. The number of pointers we're going to rearrange is not going to depend on how many nodes we have in the list.
Is having a tail like the definition of a linked list, or is that's like a?
Is having a tail in the definition of a linked list? I would say no. I would say in order for it to really be a linked list, you just need to have a head. But Judy, do you have a?
I agree.
Okay.
So
It could be an optional feature.
Optional feature. Yeah. So if you didn't have a tail, what would if we had no tail pointer, and now I want to add to this linked list, how would I do it?
just do a next, and then if it's null, then you can indicate that by the null that's your last node.
Okay, when you say do a next, what do you mean do a next?
Like if your next method, you have a next method on your node, and you like boolean that to see if it's true or false. If it returns false, then you can indicate that that's the last node on your.
So I can look at this, but how do I get here? Like how do I get to this in the first place to know that that's my last node?
Take the length and do the last length -1.
You can't do that with linked lists. I'm very glad you said that. No, I have basically this linked list right now. What I have is I have head, right? That's the only information I have. Get that smirk off your face. That's the only information that I have about this linked list. Okay. I have no idea where all these other nodes are. Like absolutely no idea. The only way, if I have no tail, the only way no smirks. The only way I can get to this particular node is by starting here and traversing the list. So I start here. I say, is your next a node or is it null? And it says it's a node. I'm like, great. Now I'm looking here. Is your next a node or null? The node. Node or null? Node. Node or null? Node. Node or null? Node. Node or null? Node. Null. All right, I finally found my last one. That's the only way to find the last node in a linked list if you don't have a tail.
Or if you don't have a length method that you wrote.
Even if you have a length method, if I asked you for the fourth item in this
Okay, I
linked
get what you're
list,
saying.
yeah, you
There's
can't
no-
tell me. There's no
no
pointer
reference
to
to it.
4. right? If you want that, then linked list is not the data structure for you. If I were to delete the head of the linked list, what's the runtime of that? Or what steps would I need to take? What's the runtime?
O1.
Why?
Because you have a pointer at the head, so you're just going in and doing one thing, just like removing.
Okay,
You don't
so
have to
if I'm deleting the head, what steps do I need to take?
You need like a
Well,
temporary head, or like you'll need to like take heads next and set it to be like the new head, and then you can delete the head.
Mhm.
Right.
That just deletes it, right? Like as soon as you.
You don't even need to delete it. Like,
Just
as
get
far as
some-
this linked list is concerned, this is nothing. There is no way to get to this. This has no association with this linked list. It happens to point to something in the linked list, hooray! But there's no way you can get to it.
So you just have to reset the head, and then that
You
makes
just have to
it
reset the head.
Wouldn't you want to delete it though, so it's not taking up memory though?
Garbage collection. We haven't talked about garbage collection in here. But basically, most programming languages can detect when a piece of memory is no longer being used and free it up. Garbage collection. All right.
Our computers have an Oscar the Grouch.
Because I love trash. Lower level languages, you have to deallocate the memory yourself, but with JavaScript, garbage collection. Okay. So cool. Right. O of 1. Do you remember what the runtime was to delete the first item in an array?
Constant.
No, it's O of N.
that's all then, because you have to move everything forward, right?
Because right now we have 0, 1, 2, and so forth. And if you delete the first one, you have to reset the numbering of the array.
Mhm.
Again, it's like if you have a list on a piece of lined paper and you need the first item to be on the first line, if you want to delete the first item, you have to erase that, and then you have to erase everything else and rewrite it on the line before. This is one place where a linked list has a huge advantage. Deleting the first item in a linked list, constant runtime. Yeah, Stephanie.
Can you give an example, like a real world example, where someone would be like, I need you to do this. And then you are thinking like, okay, should I use a linked list or should I use an array?
I can. And the answer is an implementation of a queue, right? There's a reason that I went through this whole thing and reminded you about that. If you have a queue, remember how when we were using an array for a queue, that dequeuing was O of N.
Mm-hmm.
But if you use a linked list, dequeuing, O of 1. Enqueuing, as long as you have a tail, also O of 1. Peeking, O of 1. Is empty, O of 1. Better for queues, linked lists are.
Okay.
Cool. Shall we do some programming?
Yeah.
Take video stop. Okay. All right. So let's do that, and then we'll do this. And so not there. Where was I? thought I had this up already, but apparently I didn't. Okay, so if we look at this article, basically, when you're writing code for a linked list, you have, oh, and let me make sure I'm sharing my screen so that the recording can see this. Hold on. Okay, so you have these two, we call these, these are really acting as classes. We have a node class, and we have a singly list class, singly linked list. Oh, by the way, what's the difference between a singly linked list and a doubly linked list? Yeah, Mira?
It has access to both
Mm.
next and previous.
Next and previous. Yeah, because let's actually, oh, I know I promised you this. Well, deleting the tail. So deleting the head we said was constant. Deleting the tail.
If you have a pointer at it, it's constant.
Okay, so let's actually, all right, I'm gonna turn the camera back and let's stop sharing my screen and get.
Bonnie, is it O of N? Because you have to find now the last one it's in.
Exactly. In order to find what to replace tail with, sorry, I'm just not going to do that for now. This is a mess. This is not really, okay. All right, well, I'm going to do the best I can. In order to, so it's fine. I can certainly, replace tail, or wait, hold on, I don't have a tail on this one. So here now, I have a tail, and I can make it so that tail doesn't point to this one anymore, right? But how do I know what tail is supposed to point to?
O of N.
I have to start at the head and go all the way and find it. Do I finally find the one that's pointing to this node? And then I can delete that pointer, have this one point to null, and point tail here. Yeah, Patrick.
So when people actually use linked lists as data structures, is there any reason not to just use a doubly linked list?
If you know you're never going to be deleting the tail, and memory is incredibly scarce, because if you're using a doubly linked list, you have to store the data for the node plus its next plus its previous. So you have to store a little bit more. But in general, no. So doubly linked list, you always have a pointer to what comes before you in addition to what comes after you. And that way, now we can have it be constant to delete the tail, because we delete this pointer, we see what came before us, and then point the tail there. Okay, so that's the virtue of a doubly linked list. Okay, so show the screen again. Okay, but for a singly linked list, each node just has a this dot next. Okay, so let's just do some. Great. So I can make some nodes. I can say const gen equals, let's see, new node, and I'm just going to give it data. So the data is going to be Jen's name. That's it. So here's Jen. Jen is a node whose data is Jen and whose next is null. Jen does not point fingers, right? Now we'll do Mira. So now I have Mira and I have Jen. Now I want Mira to be the first item in my linked list. So how do I, and I want Jen to be the second. So how do I make that happen? Well, yeah, that's yes. Right now I actually don't have a linked list. I just have a couple of nodes, right? I can make Mira point to Jen by saying Mira.next equals Jen. Notice that these are the nodes and not the strings, right? I'm not saying Mira.next equals Jen. Okay, so now Mira has a next, and the next is the node Jen. We don't have an actual linked list because we don't have a linked list that's a head, right? So if or that has a head. So we can make this singly list. And I can now make this into a linked list by, I can say const LG, Learners Guild, equals singly list. And singly list doesn't take any arguments. So I'm just going to do a new that. Okay, so it's just a singly list. And now if I want this to become my linked list, how do I do it?
LG head is equal to Mira.
And then you have to say what the next is.
Mira's already got a next. So LG, my head is this node that has data Mira, and whose next is this node.
Would it be incorrect to call a node, like if you don't have that singular list structure, you just say like that your list is the node that is the head?
Yeah, that's a good question.
That's what Celeste did.
That's what Celeste.
That's what we did too.
Yeah.
We didn't bother making a single list class. We just wrote our function against the head.
Which is totally something you can do, and it's actually pretty common for trees also to define your tree by the head. Like what do you need to define a tree? You just need the root node. I know we haven't talked about trees before, but yeah. What is this class really giving us, especially if we're not tracking the length? It's not really giving us anything. Because this class is basically just a couple of properties. I set the head property, but I didn't set this property, right? This doesn't get updated automatically. Yeah. Yeah, I'd have to do this dot under, not this, sorry, LG underscore length equals 2 at this point. This should make you feel really uneasy.
Yeah, I don't like it.
One of the reasons it should make you feel uneasy is, what if I said this, right? Yeah. And so what does it mean that it has an underscore in front of it?
I think length is a built-in on functions, right?
It's reserved. Yeah, it's like it's a method. Already a method like this.
What do you have to say, Jen?
It's a thing
Oh,
that you
second
probably
node.
shouldn't be like, yeah.
It's internal. It's internal to the linked list. You are not supposed to be dealing with it. Yeah.
That's what the underscore means?
That's what the underscore means.
So like when it's underscore dash.
Is that
If
by
it's-
convention? Or is it-
That's by convention. But basically it's like, if I wrote this singly linked list, right? And I'd spent so much time and effort and I sold it to you for $100, right? And you were working with it and you started doing things like, and then you come to me and you complain that my linked list isn't working and you want your money back. I'm like, screw you. You're obviously not supposed to mess with things that have an underscore.
Ah.
Is that why JavaScript,
I'll
like
see
the
you in
prototype
code.
on objects is like underscore underscore?
Well,
Yeah.
that 2 underscores, dunder is what you call 2 underscores. Dunder prototype. 2 underscores means that it is something special, like but also automatically populated. Yeah, I wouldn't. I don't know. When you're like I can just speak to Python because I know Python better. When you're creating classes, you often do write these dunder methods, but the dunder methods are they're hooks that the programming language is going to use when you make your class, right? They're reserved also, but they're, when you're making your new class, you can certainly use them and you want to use them. I don't feel like that was a great answer. Sorry. But yeah, definitely if you have like dunder properties in your class, yeah, those aren't meant to be exposed either. Yeah. All right. So we now have LG. Oops. LS, just my fingers just want to do LS. Okay. Let's add a couple more nodes. So we're going to do this by hand. Well, we can. For my singly list, I'm going to make, I don't like singly list anyway. So I'm going to make a, let's make a new, let's actually start doing this outside the REPL. And I'll save this and I'll also expose this code. Let's see. So I'll make a new one and I'll save this in a new folder called linked list. And I'm going to say just linked list.js. Okay. So, wait, what? Okay. All right. So let's just go back up here and get, we'll do, wow. All right. So we'll make our node. And then we will make, why are these capitalized? Because they're classes. Okay, so I'm going to say this dot head equals null. And let's actually make some methods. How do we make a method on a class? Yeah, so this dot prototype dot, let's say add node. And let's actually just make it take data. Let's see.
When you say let's make it just take data, what else could it take?
It could take a node. But what I'm going to do is I'm actually going to, so this is going to take data, which is, let's see. It can be anything.
But it's, I'm confused. You're adding a node. It's a function that you're calling add node.
I'm adding a node, but I'm only going to add it using data. I'm going to actually create the node inside the add node function. Have I offended you?
No. Just trying to make my brain understand it.
Basically, when I add a node, I want to be able to add it just by supplying what data I want the node to have, and I don't want to have to create my own node first and then add it. Okay, so. Okay. Expected 0 arguments, but you got 1. Okay, I'm gonna ignore you for now. And then, well, let's say that we have a tail too. So what if I say this dot tail dot next equals and then I say this dot tail. What do you think of that?
You'll have to have it checked for when you add the first node.
This is good as long as we have a tail. If we have no tail, it's going to be like, I have no next property of null, right? So create the node. And so this is if there is at least one node already. If this is the first node, what do we do? First of all, how do we tell if it's the first node? What's a check we can do to see whether it's the first node?
Say if the bang is
Ahead exists.
Ah, so what would I type here? If bang what?
Head.
Like this?
Yeah. This stuff.
Yeah, we gotta do this. This dot head. If it's the first node, then we'll have no head. Very sad. I know, but never fear. So now what am I gonna have to do? Okay, well, either way, I'm gonna have to make a new node, right? So we'll do that. Okay.
So the new node equals this one.
Like that?
Or head equals this.
Yeah, we've got to put this dot head on this side, right? We are assigning, we already know what new node is. It's this. And what we're changing is this dot head. Ta-da, we're done.
So just one element, and it's both head and.
It's both head and tail.
For now.
For now. Okay. All right, questions on any of this? You following?
Yeah.
Jen, do you have a question?
Mm-mm.
Okay.
Is your node actually able to be defined? That's why it's sacred?
Yeah, that's a great question. What's your problem here? Duplicate identifier node. But where else is it identified? Is it here? I'm confused as to where else it thinks node is.
Or maybe it's reserved for. No.
Yeah, that's a great question, Jack. VS Code is rarely wrong, but occasionally it is, and I don't understand where it thinks it's duplicated, where it thinks it's also. Yeah, Jen.
I would like to point out that it works on my machine.
Are you using Atom?
No, I'm using VS Code.
And VS Code doesn't have a problem with this. Let's just try it and see what happens. And so what we can do, and so I actually want to just node. Oh God. Okay. Okay. So I didn't get any errors here. That's a good sign. And now if I do const gen equals new node. No, actually now what I want to do is I want to say const lg equals new linked list. Oh man.
Is it because Yeah, I was gonna say.
Oh.
Put the prototype outside the.
Yes. Okay. Clearly, yes. Thank you. I do have. I'm very Pythonic when it comes to object-oriented stuff. That's my excuse. So, okay. So now instead of this dot prototype, we're gonna say linked list dot prototype. We good there? Still, it's still upset up here. Okay.
What's that new node on 916? I think that's it.
Yeah. What? I really don't understand why you're expecting 0 arguments. And maybe node is a reserved word. Maybe I am. So let's call
I have the same
LL. I'm gonna call it LL node. Yeah, node is a reserved word. So
Well, I have the same color, and it's like not.
yeah, it's because you're clobbering the built-in node, right? So if I just do like node here, notice that it already has something, even though like, oh no, it's not. All right, so I don't know. Okay. Anyway, great. So now if I do LG equals new linked list. Now I have nothing in my linked list, right? Oh,
Yeah, that worked.
You're doing a circular, huh?
kind of. It doesn't like my next.
We kept getting circular too. It's circular.
Yeah, that's nice, but not what we were going for. So why? Because new node should just have new node next should be null.
If you did lg.head.next, it would tell you.
Okay. Let's console log.
I know if you make your head and your tail the same thing as implicit.
No, it's not, because it's just like basically what you have. Sorry, people on the recording. Basically, you just have head pointing here and tail pointing here, and this just points to null. That's a perfectly legit linked list. I don't understand why it changed my next. Linked list. Sorry, Jen. Too lazy to capitalize you. Okay, so here it thinks its next is null. But then somehow it changed its next when we assigned the head and tail. Just doesn't make any sense at all, does it?
You're saying
Aren't you changing the head?
Yeah, if there's already at least one node.
You don't have the if there is already. You should checks to see if there's at least one node.
But that's the if not this head.
Yeah, but then you're running line 27.
Oh, the else. So smart, the wisdom of the crowd. Okay, let's try this. And actually, I'll do LG equals, I'll just do this so I don't have to type it every time. And again, I know in Python how to load a file like this, but maybe require would have worked. But anyway, so LG, great. Much better. Okay.
Good catch, Celeste and Patrick. Okay. Oh, Jack. Sorry, Jack, you're too far away for me to acknowledge you. Just kidding. Okay, so. Okay, so notice I added Mira, and look at that. It like automatically set my next for me. Fantastic. Let's see, poor Jack. Let's do, now it's like getting lazy. It's like, dude, I'm not gonna write all that out for you. But if I did lg.tail, there's Jack.
Would Mira point to Jack?
Yeah. Yeah, Mira does point to Jack. You can see that the head is Jen and its next is Mira, who points to Jack. If I want to traverse this linked list, I'm not getting to reversing. Reversing will be left as an exercise to the user. But let's traverse the linked list. Let's just write some code to traverse the linked list. So what's that code going to look like? So when I say traverse, I mean look at every node and print out its data. So we can make it a prototype, sure. So we can say linked list dot prototype dot traverse. Okay. Why? Why do you hate me?
Don't need to invoke.
Thank you. Okay. Equals. Okay, so what are we going to do?
Can you do like while this dot tail dot net is not equal to null?
Now I'm going to have a problem here because when I traverse it, I do not want to change the linked list at all. And which means that this dot tail is not going to change at all, which means this dot tail dot next.
Well, this dot next.
Oh, okay. But this is what? What data type is this? It's a linked list.
Oh, it's referring to it.
So you have like a current node, and you start at the head.
So current node dot next.
Yeah. Now, but the thing is, I think I actually want to do while current node. What if I have an empty list? Okay, so while current node is not equal to null, I am going to do console log current node dot data. Remember dot data?
Can't you just say while current node?
Yeah, I could. Got burned this morning because some things were falsy that I didn't expect to be falsy. Okay, or vice versa. But okay, yes, I could in this case. So while current node, we're going to console log, and then what are we going to do?
Return. All right.
This is moving the pointer along.
Current node equals current node dot list. You always have to tell the linked list where it's headed.
It didn't do what I wanted it to. Let's just start there And then we can also, well, actually, can, and then, okay, just see what we get here. Okay, it has a head, so why isn't it getting it? Why isn't this?
The link.
Crap, is this? Oh no! It's binding. Oh, poor me. Okay. You don't have these problems with Python. So now we've got now we're traversing properly. Oh, I didn't redefine it. Much better. Okay. How are you feeling about linked lists?
Doubly linked lists are better.
Okay, so here's what I recommend you do if you want to spend some time with linked lists. Implement a doubly linked list the same way I implemented this singly linked list. Implement add node for a doubly linked list, right? And then, yeah, the classic linked list problem is to reverse the linked list, right? To take the linked list, make a new list that is the reverse of the original list. Do it with a singly linked list, do it with a doubly linked list.
Check, check.
Did you finish that in an hour? Nice.
They had Patrick.
Yeah. Well, dang, Stephanie. No, that was a serious chat, but okay.
Brittany, what did you want to?
Into the conference we could all share.
Okay, you're gonna take this outside, but Brittany.
Yeah. So could you? I think Stephanie asked earlier, but like, is there like a situation like in an interview question or an algorithm problems question where I'd be like, oh, I should use a linked list for this?
Oh, is there a situation?
Because on front end masters, they said you like never use linked lists for like anything.
Except interviews. Yeah, so cracking the coding interview, we have a copy. I haven't checked recently to see if it's still on the bookshelf. Does anybody happen to know where it is if it's not on the bookshelf? Okay, all right, so ask Mita. Cracking the coding interview has has a whole chapter on linked lists. So you can look and see what kinds of questions. Yeah. Interview Cake also has a bunch of linked list questions.
Judy just posted a link.
Ah, thanks, Judy.
Everybody's squad channel and it's in general.
Okay.
I got my account. Do it this week.
Oh, okay. Do Interview Cake this week. Cool.
Or make sure you set up your account. The subscription lasts a year.
And it's free.
Yeah.
Otherwise it's $200.
Then you got a volume discount.
Okay. Yeah. So be comfortable working with the node and the linked list class. Do it a lot.
Yeah.
Nodes you have not seen the last of. We will see more nodes when we do trees and when we do graphs. But next week we're going to take a little break from data structures and talk about recursion, because it's nice to talk about recursion before you talk about trees, because trees are recursive objects. So linked lists are too, actually, but every linked list is a tree, but not every tree is a linked list.